So both of these are still FNet equals MA questions. If it's constant speed, then A equals 0, and if A equals 0, FNet will equal 0. So your ups equal your downs, everything's balanced. So like, and vice versa, when they're balanced, it causes no acceleration, which is then constant speed.
Why is it constant speed? Oh, because there's no acceleration.
Because they're equal.
Right. Okay, that's just something I have to keep in mind.
Okay.
The person is lowering a bucket into a well with a constant speed.
Yeah, bam, constant speed. Constant speed, zero acceleration, zero acceleration, no net force, so everything's balanced.
Block of mass M slides down a frictionless plane inclined at an angle theta with horizontal. The normal reaction force exerted by the plane on the block is directed perpendicular to the plane. That's what I didn't get, I think.
So normal force, in fact the word normal itself already means perpendicular, which is the answer to question 6, I think. But remember when I did the thing with the thumbs up? Did you have that in your class? Like if this is my surface, normal force will always be the direction of the thumb. So as the surface tilts, it tilts because it's always perpendicular to the plane.
Right, that's what I was thinking when I put E, but I guess that's not the right.
E would be, oh, yeah, no.
Okay. A block of mass slides down a frictionless plane inclined at an angle theta with the horizontal. The gravity. Oh, that's right. I don't know why I said perpendicular to the plane. Maybe I didn't read it right, but I understand what the mistake is here.
Okay.
An object rests on an inclined surface. If the incline of the surface is made steeper, how does the normal force change?
So this is a hard one to do. Like you could do it with algebra and we could set up all of the things. Like I think a previous question ends up having Fn equals mg cosine theta as its answer. Now, if you happen to already have that math figured out, then sure. As theta increases, cosine theta decreases, so Fn decreases. That would be one way of doing the problem. The way that I would recommend, though, is I would draw 4 pictures. You're going faster than I am, it's crazy. Alright, one of these questions has no normal force. Which one is it?
No normal force? Fourth one.
Yeah, this one, right? It's just gonna fall straight down. So Fn equals 0. But I know that over here, I definitely don't have Fn equals 0. Fn is actually, in that moment, it's just sitting on flat ground. Fn is equal to Fg if it's on flat ground. So Fn is equal to mg. And so it's a progression where Fn is the biggest at being being mg, and the smallest at being 0.
Right.
So as your angle increases, the normal force decreases.
That makes sense. Two objects have masses n and 5m respectively. They both are placed side by side on a frictionless inclined plane and allowed to slide down from rest. I'm guessing this one, the answer is E because it's like frictionless, so.
Even if it was frictionless, it actually would still work, but you don't have to worry about that. That would be a pretty spicy question. First, let's talk about two objects that we just dropped. Okay. Could you grab me a tennis ball? Okay. So people on the camera won't be able to see, but just listen for it, I guess. When I drop them, listen to see if you hear one bounce or two bounces. Kind of sounds like one, right? It doesn't sound like don't, right?
Yeah.
They're falling and they're hitting at the same time. Now that doesn't feel natural because we expect the heavier one to hit first. But let's do the math. If even for this situation, I do FG as my free body diagram, then Fnet equals MA. I've only got one force, so FG equals MA. I've got MG equals MA. True?
Mm-hmm.
All right. Now what this says is that objects that have more mass are more resistant to accelerating. That's intuitive from bowling. If I try to bowl with the super heavy bowling ball, I don't get it moving very fast. But gravity has this, I don't know, quirk. It's not actually the best way to say it, but it's got this interesting aspect that the more mass it is, the harder it pushes on it. So even though the bowling ball is heavier to push, gravity pushes on it harder.
Mm-hmm.
And even though the tennis ball is easier to push, gravity pushes on it by less. And so the net result is that mass cancels, and all objects will accelerate at the same rate if gravity is the thing responsible for pulling them.
Oh.
Yeah?
These ones were when things started to get challenging.
Okay, starting at 19?
18.
Starting
I
at
don't think I finished that one.
Okay. So a couple of things, and it's been a common misconception. When it says left of the vertical, that's telling you where to draw your angle. What you did was you drew above the horizontal. Do you remember way back when
But
we
isn't
said
the
like,
left of the vertical?
yeah, but you see that you connected to a horizontal line, and then from there you went above the horizontal.
Does that mean the other side would be?
You
30?
also do that one above the horizontal. So this,
Is it 35?
yeah.
Um,
So starting from vertical, go to the left of vertical. So there, theta equals 35 degrees. And then the other one, yeah, is similarly looking for that angle. Just put theta for now. Okay. I'll use your picture. this one is 600. This one's 1300. The important words for this one is accelerating vertically. So I know based on this that AX actually equals 0. It's a little tricky. They tell me that it's accelerating vertically, and what I get from that is that it's not accelerating horizontally. And so if AX equals 0, then FNet X equals 0. Nobody's winning side to side.
Okay.
So keeping in mind that this angled force of 600 has some component that's going sideways and some component that's going up, and this 1300 has some component up and some component sideways. Based on this, I can say that that equals that. So I don't know how you want to name it. ft1x equals ft2x.
Okay.
Are you processing that? Is it?
We do know that they. How do we know that they equal each other?
Because there's no winner side to side.
Oh, that's right.
So the formal proper way would have been for me to start with fnet x equals max, but then there's no winner there, so fnet x equals 0. Fnet x is ft1x minus ft2x equals 0. ft1x equals ft2.
Okay.
So let's
And
figure
then
it out.
do we do like the sines, cosines? right?
Exactly. So this one is 600 sine of 35, and that one would be 1300 sine of unknown.
And then would it be like the, what is it called? Like the sine to power of -1? The answer.
Now, based on your decimal answer, I'm guessing that you're in radians right now.
I switched it.
Maybe.
Yeah, I switched it to degree.
Okay, then I was wrong. Like I said, it was a guess. Nice.
How many questions do you think are gonna be on the,
I would guess somewhere in the 30 range. That's my guess. '19 is made way easier by the fact that it's a smooth surface. The smooth surface is telling us that it's no friction, which makes life way better.
Horizontal. The pulling force is 10 newtons
Hmm.
and is directed 20 degrees above the horizontal.
Right, so I drew my horizontal, and then I drew above the horizontal.
Oh, so it's like being. Okay.
Nice.
What is the acceleration? So we're trying to find AX.
Mm-hmm. Okay. What formula has AX in it?
I don't remember.
I believe in you. It's the same formula that we've been using for like every problem.
F, G, F, oh, F net equals M, AX.
Yeah. So if I'm dealing with the x direction, then my acceleration is in the x direction. Now it is not a straight 10 though. Because this 10 is happening at an angle.
So it's,
Some of that 10 is directed vertically, and some of that 10 is directed horizontally. You seem confused about
so
that.
did we find the sine or the cosine?
We want the x part. So is that sine or cosine?
It's cosine.
Got 10 cosine of theta equals.
Seems so complicated.
So once again, it is a smooth surface. So once again, our labs are made way better.
The pushing force is directed at an angle 15 degree horizontal. What is the acceleration? So F net equals MAX. And we find again the cosine. And
Cool. Now one adjustment I want to make to your free body diagram while you're here. That is not 392.
I don't know why I wrote that.
I've never seen that arrow a day before in my life.
I don't remember. Listen, this was like on the first day. I don't remember what I did on Friday or.
So yeah, FG is equal to 392. That's just 40 times 9.8.
Oh,
Um,
right.
if we had the force of friction, then we would have an arrow there. But since we don't have friction, we don't have that. Cool. All right.
that like basically not the same problem, but the same type of problem?
There's three cables and you just need to make them balance. So you're gonna end up doing add up all the things left and right equals 0, add up all the things up and down equals 0.
Mm-hmm.
West of north, so compared to north, it's west of north. Oh, there's only 2 cables, my bad.
What does it mean by will accelerate northward?
It means that at the end of the day, it's going to travel straight north. So it ends up actually having the same kind of setup as where the problem that says like it accelerates purely vertically. The information that that's telling us is that it doesn't accelerate side to side.
Mm-hmm.
Yep. So actually, once again, it ends up being the same problem. We just need to equal each other. Sorry, I should have let you do that. For viewers at home, that's the sine inverse of 0.33. Nice.
Oh. I forgot what we were doing for a second.
You were crushing it in that section.
Yeah, I'm pretty sure that's when I like looked at the answer key and tried solving backwards.
It's supposed to read scale.
So I think I didn't know what is it called? What I was supposed to use.
Okay.
Equation.
Draw a free body diagram.
Is the magnitude of the acceleration just asking for like acceleration?
Yeah. Yeah, magnitude means ignore the direction.
Mm-hmm.
Okay, couple adjustments before you get too far. The scale is our Fn. So the 400 is happening actually right there. And then Fg, go ahead and calculate Fg equals mg. Okay, so that is what's happening right here. So when you end up actually doing Fnet, we're not going to have the full 400 because there's a game of tug of war happening. So it'll be the 400 minus the 352.8. What?
Did I do it right though?
The process is right. Let's see.
Oh, no, light correction. I think the locker is this way, so even your doorway is still
Hey.
with it. Can you tell how much cleaner? You should have saw the water.
Oh man, I bet.
No, I didn't feel it where I think the flood would put a hole in it, so. I thought, you can always kind of see where it's at. Yeah, if I'm there, the door will open. Alright, 91 days, HGBs.
All right, I'll look into the answer key for 28. Because your process is good.
Okay. Oh, this would have been one of them.
So these ones look very similar to the ones that we've done not too long ago. So maybe skip them. Maybe try them at home.
I think the problem with this one was that it said like on either side of the vertical direction, and then yeah.
So, forgive me, I've lost track. Did I explain that? Did I explain this question to you already, or
I don't,
just other classes? Because I talked about not specifically this question, but there's a bunch of classes I got to the result of Fn equals mg cosine theta. It's just something that they just
I
know.
think we talked about that.
So if I commit to just like tilting my head sideways, I get this as my x direction and this as my y direction. So then I know that it doesn't leave the surface of the plane. So my a in the y direction equals 0 because it's not lifting off of the plane and it's not destroying the plane, it's just staying on that line. Yeah.
Okay.
Which means that all of my y direction forces balance. So Fn is equal to Fg in the y direction. Yeah? But Fg quote unquote y is equal to mg cos theta.
Take a picture of that. So, how would you go about solving this? Just another question.
So since FGY and Fn are the same size, that just equals Fn. And now they just give us the numbers. So now I just do 30 times 9.8 times cosine 27.
Sorry, what's the G in MG again?
9.8?
Oh, that's right.
Cool. So we're good on that?
Yeah, I just wanted to explain these to me.
So velocity, so acceleration is change in velocity, but velocity has two parts. Velocity is made up of speed and direction. So even if speed is constant, if the direction is changing, velocity is changing, and if velocity is changing, that's acceleration.
Okay. So it does change direction every single.
Right, so in order to turn on a circle, F net needs to be towards the center. And F net will always be in the same direction as the acceleration. So at all these different moments, the acceleration is always towards the center, but it's changing its direction.
And because, yeah, because direction changes, or acceleration changes.
Okay.
Why does a cyclist tilt her bike on a curve? I didn't know that answer this one because I don't think we really ever talked about it.
Well, if this is the bicycle seat, so it used to be straight up, but I need some force pointing towards the center of the circle. In order, right? Because you need a force towards the center of the circle in order to make a turn.
You're driving your car and see your glasses on the dashboard. Make a left turn. The sunglasses go sliding off to the right. I understand this one. I
Okay.
don't know. I think maybe like another problem came up later where it explained it. Was it's like because the sunglasses continue going straight while the car turns right, and it makes it look straight.
Perfect. Yep.
Block of mass is on an inclined plane that makes angle theta with the force of static friction must be such that I didn't understand what this question was like.
So the simple fact that it says static friction means that it's not moving. And if it's not moving, I need some force pointing against it sliding down the hill. Yeah. So my free body diagram, if there was no friction, right, that's just the ramp, would be Fn and Fg. But since there is friction, friction is resisting sliding down the ramp. So let's do those weird crooked Y and X. So let's do those very crooked ones. Which means I need to turn Fg into a weird crooked one.
Why is it mg sign specifically?
Because in the same way that in the previous problem we said this needed to balance this, and this was the mg cosine, because our angle was right there. We need friction to balance this portion. This is the portion that's pulling it downhill. And so I need this and this to cancel, and this is equal to Fg sine of theta, because it's the opposite.
Oh, I see.
So Fg sine of theta at minimum, it needs to balance FG sign.
The block of mass is at rest or on an inclined plane that makes an angle theta with the horizontal. The normal force Fn acting on the block must be such that. So let's put it this way. The normal force would be perpendicular to the plane.
So the normal force is right there, which is balancing with it.
That force.
Is that going to be sine or cosine of that angle?
Cosine. Oops. We're going with the pulley questions.
You guys get so stressed out by them, but they're not bad.
I don't remember anything about them. I tried finding notes. Doing 30 questions a day took me like 2 hours at least. And it is. And I tried looking back in my notes and I tried like solving backwards and I don't know where the pulley questions went.
I don't know where they went. Alright, let's figure it out. So, a very convenient thing is that it's frictionless. And so let's think about this as a big group. Alright?
Because I know you need to like add them, but I don't know where you add them, how you add them, something, that, the other. I don't know.
Does this box do any pulling?
No.
Does it do any rubbing? No.
Because it's frictionless.
Because it's frictionless. So really this one adds no forces to this situation. It's just along for the ride. This is the thing doing all the pulling. And so I've got this much pull for this much stuff. The equation that relates pull to stuff is, you guessed it,
Just that?
Yep.
Okay.
so what's my pull? One object's weight.
Not MAX? Oh, it's
Well-
acceleration. Wait.
I'm just leaving the x off because then I'd have to talk about how this is my x direction,
Oh, okay.
and I just didn't
That's
want
what
to do
the
that.
X is
But you called me out on it, so then I talked about it. Alright, so the thing that's actually pulling is just this one box. It's the force of gravity on that one box. So it's the M and the G. But the stuff that it's responsible to pull is both of these. So 2M.
Oh.
Does that make sense?
Yeah.
So if they wanted to, specifically the acceleration would be half of the acceleration of gravity, but they left it as less.
Do you promise this test won't be like uber hard?
Can't promise that because I don't know how people think.
Okay.
There's been a lot of times where I've promised the tests aren't uber hard and then kids promise super hard. But most of the time, then when they look back at it, they're like, "Oh, Mr. Berger, you actually made this super easy." Yeah, like I really wanted you guys to do good.
Is this also just F mag equals MA and G equals MA?
Yes.
So this one would have the MG of -4. Oh, actually, I wrote that.
But
down
does
already.
that one contribute any pull?
So we're only looking at the one that contributes pull?
Yeah.
Okay. 19.6. And it would be 5 MA, right? Because
Yeah, because all of the stuff adds up to 5. Be a little less than 4.
oh my god, I understand it now.
You did it.
Okay. Yes.
All right. Now the thing that's different about this question is that it's a rough table. Okay. So up until now, this force was the only thing in the game. But now I also have friction fighting it. So then there's only 2 forces. Alright, so I've got this force, Fg for B. And realistically, it's going to win. But it's being resisted by FFK from A. Those are our pulls. And we're still going to end up doing, all the mass needs to move. So this is MA plus MB. Okay, you good with that? Yeah.
We would just do the same thing as up here, but
Minus the friction. But it takes a little bit more work because friction is equal to mu times Fn. And so I have to know, okay, this one has its Fg and it has its Fn. So first I figure out Fg for this bad boy is 2 times 9.8. So that's 19.6. So this is 19.6. So this is 19.6. I can tell when I'm going faster than students are ready for when the phones come out.
I'll just copy it down.
Okay, so could you calculate that number for me though? 3 times 9.8 is 27.6.
Which is 9.8?
Yeah. No,
27.624.
Right. So the process is still the same, and there's just extra hoops of figuring out the force of friction.
Oh, it's 57, not 27.
3 times.
3 times. Oh. Sorry. But they were asking like the 5.88 times 9.8.
No. So then you subtract those and you divide by 5.